Good morning, everybody. Today we are going to discuss last chapter of our first part of last chapter of our curriculum, input-output interfacing, I/O interfacing. In fact, I/O interfacing is going to play a very important role as far as edge-086 interfacing is concerned. Because whenever we are talking about 8086 interfacing, we need to understand how, what are the hurdles, what kind of precautions we need to take whenever we are talking about interfacing. But before that, we need to understand what is interfacing. So interfacing matlab kya hai? Interfacing is a connection between two devices. So whenever we are talking about connection, so we need to understand whenever we are connecting one device to another, what are the probable difficulties, right? So one of the probable difficulties would be a mismatching, right? Because whenever we are talking about even like friendship, let us say you want to get connected with your friend, right? And you must be having, let's say in your class, you are having, let us say 50 students. You are not going to have a friendship with all those 50 students. The reason is compatibility, right? Reason is mismatching. So out of 50 students, you might be having good connectivity with maybe 5 to 10 students, right? What does it mean? It means that you are going to be very, very compatible with those 5 or 10 students out of 50 students which you are having in the class. The same thing is true with the devices as well. Whenever we are talking about connecting devices to processor, we need to understand the compatibility issues. We need to understand how, like the main important issues which we are going to face whenever we are connecting one device with other. Now, as far as 8086 interfacing is concerned, there could be two different topics of interfacing. One is memory interfacing, other is input-output interfacing. In fact, we don't have the memory interfacing included in the curriculum. Therefore, we are going to discuss the various aspects of I/O interfacing. This is what I was talking about, interfacing of I/O and peripheral devices. Peripheral devices means what? Peripheral devices means the devices which are in the periphery of 8086 microprocessor. Okay, devices which are in the periphery of 8086 microprocessor. Let us say I/O devices. In the periphery, you could have the memory devices as well as I/O devices. And today we are going to discuss only I/O devices. So why we need to have the interfacing of I/O devices? What is the purpose? For communication with microprocessor and outside the world. Because whatever data you are having, if you really want to give data, because for example, microprocessor is going to use to process huge amount of data. So for what you need to do, you need to provide some data for processing. For that purpose, you need to connect input device. Once the when the data is processed, that need to be displayed on output device, or that need to be transferred on output device. So you need to connect output device as well. So connection means interfacing. So in order to communicate, in order to have communication between microprocessor and outside the world, we need I/O devices interfacing. Then what are the probable I/O devices? Keyboard, CRT display, printers, compact disc, etc. These are the probable I/O devices. So you can visualize like this. This is microprocessor and this is I/O devices. We need to have a interfacing between these two. So these ports or buffer, this we take care of the mismatching issue, compatibility issue, right? This is what usually we do. Like whenever, if like for example, you are not, if you are not able to have a good relationship with your colleague in your classmate in your class, what you are going to do? There will be one student, he will be standing in between and helping you to minimize your mismatching, minimize your differences, and as a result of that, you can have a good friendship with many students. So like that, in microprocessor, we are going to have ports oblique buffer ICs, which we are referring as interfacing circuitry. That interfacing circuitry essentially will be dealing with mismatching issues between microprocessor and I/O devices. This interfacing circuit is going to be very, very important. And in this chapter, we are going to discuss all those interfacing circuitry which are going to play important role whenever you want to interface I/O devices with microprocessor. As far as data transfer is concerned, because whenever we are talking about data transfer between microprocessor and the other devices, we need to we need to understand like what are the probable data transfer types, right? So one of the data transfer type is program IO, other is interrupt driven IO, and third one is direct memory access. What is program IO? In program IO, data transfer is accomplished through an IO port controlled by software. So what does it mean? It means that whatever data you are going to transfer, that is going to be transferred through IO port, which is going to be controlled by software. This is what we call as programmed IO. That is why, since it is being controlled by software, this is being referred as a program IO. Next one is interrupt driven IO. What is it? What is interrupt driven IO? Interrupt driven IO is like in this case, IO device interrupts the processor and initiate the data transfer. I mean, like you can interrupt processor through one of the interrupt control terminal, and then you can transfer the data. And third one is direct memory access, in which we are going to use a DMA. DMA is direct memory access. Data transfer is achieved by bypassing microprocessor. Bypassing microprocessor means we are not going to, like, let us say from input device to memory or input device to output device. Straightway you can avoid microprocessor. You can keep microprocessor in isolation, and you can directly transfer data from one device to other device. So these are three different types of data transfer. Um, okay. Now, as far as the program IO is concerned, in this case, we can have two different types again: memory map IO and IO map IO. We are going to discuss in detail what is memory map IO and IO map IO. Let us see what is. Let us have the comparison of memory map IO and IO map IO. In memory map IO, 20-bit address are provided for IO devices, whereas in IO map IO, 8-bit or 16-bit addresses are being provided for IO devices. Because the reason is, in memory map IO, essentially all memory locations are being considered as a IO locations, and therefore, for addressing memory, any memory location, we need 20-bit, and that is why 20-bit address are usually provided for IO devices as in memory mapping. And in IO mapping, in true sense, the IO device is going to be connected, and therefore 8-bit or 16-bit address are going to be provided. Then in memory mapping, the IO ports or peripherals can be treated like memory location, and so all instructions related to memory can used for data transmission between IO device and processor. As I mentioned earlier, in memory map IO, basically all memory locations are being considered as IO devices, and therefore whatever instructions which we are using for transfer of data from one location to another, from one memory location to another, all those instructions will be considered as a IO instruction as far as memory mapping is concerned. Whereas in case of IO mapping, only in and out instruction can be used for data transfer between IO devices and processor. There are only two instructions, in and out. In memory map IO, data can be moved from any register to ports and vice versa. Any register to port and vice versa means any location, okay, to port. Like, I mean, let us say, for example, register A, register AL, BL, CL, or AX, BX, CX. We have 4 16-bit register and 8 8-bit register. So you can transfer data from one of those register to IO ports. Which IO ports? Actually memory locations. Whereas in IO mapping, data transfer takes place only between accumulator and ports. Here, either AL or AX. There is only two ways. Either you can transfer data from ALAX to port or port to ALAX. So this is it means that IO mapping have lot of restrictions. In memory mapping, when memory mapping is used for IO devices, full memory address space cannot be used for addressing memory. When memory mapping is used for IO devices, full memory address space cannot be used for addressing memory means Q. What is the reason? Reason is memory itself is being considered as IO devices, right? So entire memory cannot be used. Some memory need to be, reserved for some special purpose. And therefore, if you are using memory mapping, the entire space cannot be used as a IO devices. Whereas For IO mapping, full memory space can be used for addressing memory. Full memory space means whatever locations we have, whatever the whatever the IO locations we have, all locations can be utilized for IO data transfer. It is useful only for small systems where the memory requirement is less. Whereas this IO mapping is suitable for system which requires high or large memory capacity. So whenever we need large memory capacity, we are using IO mapping. And whenever we are using the memory requirement is less, at that time we are using memory mapping, because here part of memory locations are going to be used, are going to be reserved for a routine operation. Similarly, for accessing memory map devices, the processor execute memory read or memory write cycle, M oblique IO bar, and this is going to be high. This is going to be high because M stands for memory and this IO stands for IO devices. You can see this is complementary and this is true. So this control terminal is one of the pin of 8086 IC. So this need to be high if you really want to use memory mapping. For IO mapping, this need to be low, right? M oblique IO bar need to be low, because whenever it is low, this is going to be activated and we can have the IO mapping. Now, let us have the introduction to IO interface, right? In IO interface, in and out instructions are going to be explained. Isolated, as I mentioned, isolated, in which direct or IO map IO and memory map IO are going to be used for basic input output interface and handshaking. Okay, we are going to explain isolated. Isolated means direct or IO map IO. IO map IO is also referred as direct IO or isolated IO, right? And memory map IO. So we are going to discuss this direct and IO map IO, memory map IO, basic input devices, basic output interfaces, and handshaking is concept of handshaking is also going to be explained. Similarly, the knowledge of these topics makes it easier to understand the connection and operation of the programmable interface component and IO techniques. So whatever the in and out instruction we are going to discuss, whatever the fundamental concept of this particular topic, which includes IO map IO, memory map IO, basic input and output interfaces, handshaking, concept of handshaking, all these concepts are going to be, once you understand this, is going to be easier for you to understand how the data can be transferred from microprocessor to IO devices. Let us discuss about IO instruction. In fact, we have already discussed this in and out instruction, but this is going to be revision because we have already discussed. Instruction that transfer data between IO device and the microprocessor are called as in and out instruction. Okay, instructions which are being used to transfer the data from microprocessor to IO device, but which registers? AL and AX only. In an in and out instruction, only AL and AX registers are being used, nothing else, right? Now, what is out instruction? Out instruction is one type of instruction that transfer the data from microprocessor to IO device. Okay, this will allow to transfer data from microprocessor to output device. Instruction is another kind of IO instruction which can be used to transfer data from input device to the processor. It means from outside word to processor, in instruction, and processor to outside word, out instruction. The IO addresses is stored in register DX as a 16-bit address or in byte P8 immediately following the opcode as an 8-bit register. So there are two options in and out instruction. Again, accordingly, there are two different kinds of addressing mode. Fixed port addressing and variable port addressing. In fixed port addressing, the port address, which is going to be 8-bit long, that is going to be stored in the instruction itself, which is going to be immediately followed by the opcode of the instruction. And in variable port addressing, the port address is going to be stored in register DX. Intel calls 8-bit P8 as a fixed address because it stores the instruction usually in a ROM. What I'm trying to tell you is, as I mentioned earlier, there are two different kind of port addressing. One is fixed port addressing, other is variable port addressing. In fixed port addressing, this 8-bit address is going to be a part of instruction itself. Is going to be part of instruction itself. And in case of variable port addressing, this 16-bit address of the port is going to be stored in register DX, and this is by default only DX register is being used. No other register is being used for this purpose. When data are transferred using in and out instruction, the IO address, port number, or simply port appears on the address bus. So whenever data is going to be transferred from in and out instruction, in means data is microprocessor is collecting data from outside world, and out means microprocessor is transferring data from microprocessor to outside world. At that time, what happens? The port address is going to be appear on address bus. External IO interface decode the port number in the same manner as memory addressing. Now decoding, I'm going to discuss you. Decoding means converting, the bigger number into smaller number. That I'm going to explain you what the decoding means in detail later. In 8-bit fixed port number like P8 appears on address bus connection A0 to A7 with A to A15 are going to initialize as a 0. I mean, because as I mentioned earlier, there are two different kind of addressing: fixed port addressing and variable port addressing. In fixed port addressing, the address of the device is going to be 8-bit long only. Okay, but however, we have got a 20 bits in address bus, right? So where this 8-bit is going to go? A0 to A7. So this 8-bit is going to be appear on A0 to A7, whereas from A to A15 is going to be initialized as 0, and A15 onwards, like A15, A16, 17, 18, and 19, these remaining 4 bits are going to be undefined for IO instruction. So undefined means it may have 0 or 1, doesn't make any difference. So whenever we are talking about fixed port addressing, you are going to have the port address 8-bit long, and since it is, if we have got 20 lines on address bus, so where these 8-bit are going to store, which lines are going to be used to transfer data? So lowest 8 lines, A0 to A7. A to A15 are going to be initialized as 0, and A16 to A19 would be A15 onwards, or A16, 17, 18, and 19. These 4 lines are going to be undefined. The 16-bit variable port DX appears on address connection. So as far as the variable port addressing is concerned, there we are going to have a 16-bit address, right? That 16-bit address is going to be appear on A0 to A15 as far as 16-bit port address is concerned. The first 256 IO addresses like 00 to FF are accessed by both fixed and variable port addressing. You can see. Now, as far as fixed port addressing is concerned, we can have we are going to have only 8-bit for port address, right? Since we have 8-bit, so what should be possible combination? 00 to FF. FF equal to 255, so there would be 256 maximum locations, right? Whereas in case of variable port addressing, the port address is going to be 16-bit. So first location can be 0, 0, 0, 0. Last location can be F, 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 F. Total 65K. Total location would be 65K. Now, out of these, first 256 IO addresses, right, from 00 to FF, are accessed by both fixed and variable port instructions. Any IO address from 0100 to FFH is only accessed by variable IO addresses. So later on, like FF, if you add 1 to FF, it's going to become 0100. So 0100 to FF is going to be only accessed by variable IO addresses. Now let us see IO isolated memory map IO first. Isolated and memory map IO. There are two different methods of interfacing IO, as I mentioned earlier: isolated IO and memory map IO. We have already discussed difference between isolated and memory map IO, right? In isolated IO, in and out transfer data between microprocessor, that is accumulator, to memory. The transfer of data between microprocessor and memory. But which part is like which section of microprocessor is going to be used? Only accumulator, either AL, AH, or AX. AL and AX only. Memory map IO, any instruction that reference memory can accomplish the transfer. Any instruction, because as I mentioned earlier, in memory map IO means essentially you are using all memory location as a IO devices. Now let us discuss one by one isolated IO. The most common IO transfer technique used in Intel-based system is isolated IO. Because this is going to be very common IO system which is being used in Intel-based system. Isolated describe how IO locations are isolated from memory in separate IO address space. That I am going to tell you. Addresses for isolated IO devices called ports, and which are separate from the memory. One thing you should remember, that in case of isolated IO, isolated IO means it is not part of microprocessor. It is in true form input output devices. So how many input output devices we can interface? Because we have got 8 bit, right? 2 to the power 8. 2 to the power 8 is 256. So at the most 256 devices can be interfaced. Addresses for isolated IO devices called ports are separate from the memory. But what does it mean? It means that whatever addresses we are going to use for isolated IO devices, these addresses will be referred as a ports, and they are going to be completely separated from memory, and that is why it is referred as isolated IO, because it is not part of memory. Because the ports are separate, the user can expand the memory to its full size without using any memory space for IO devices. Because we are not going to, in isolated IO, we are not going to use any memory location. And as a result of that, since we are not going to use any memory location, the entire memory space can be used for rest of the purpose. The disadvantage of isolated IO is that the data transfer between IO and processor must be accessed by in and out instruction. This is the only disadvantage. What is the disadvantage? Because the data transfer can be accomplished by in and out instruction only. There is no second thought for that. Separate control signals for IO space are developed using M/IO bar and W/R bar, which indicates IO read or an IO write operation. So you can see here, once this is M/IO bar is one of the pins of 8086 microprocessor. If you put logic 0, automatically IO is going to be initialized. IO is going to be selected rather. And if it is 1, memory is going to be selected. So for this purpose, you have to put logic 0 here and here. This will help you to understand how IO write or read operation can be performed. So for IO read, this should be logic 0, and for IO write, this should be logic 1, because 1 means W and 0 means R bar. These signals indicates an IO port address which appears on the address bus and which is used to select the IO device. These signals, because whatever signals we are talking about, this signal indicates IO port addresses which appears on the address bus. I mean, as far as IO addresses are concerned, those IO addresses are going to be appear on address bus, and then there are some control signal which we are going to use to enable the IC. What is memory map IO? Memory map IO does not use in and out instruction. You see the difference. In IO map IO cannot be used without in and out instruction. Whereas in memory map IO, in and out instructions are not at all being used. It uses any instruction that transfer data between microprocessor and memory. So whatever instruction which is being used to transfer data from microprocessor to memory or memory to microprocessor would be referred as IO instruction in memory map IO. Treated as a memory location in memory map. This is in true sense, this is going to be a memory location which are being used for IO transfer. Advantage is any memory transfer instruction can access the IO device. So one of the advantage aspect of is any memory transfer instruction. Any memory transfer instruction can have access can access the IO device. The disadvantage is a portion of memory system is used as IO map, which will reduce the memory space available for any other application. This is one of the serious disadvantage, that the memory space is going to be used for IO map, so there will be some restrictions for using memory. So this is one of the disadvantage. Now let us understand basic input circuit and basic output circuit. Now, what is basic input circuit? It is basically a tri-state device. Now, what is tri-state device? The device which has got three state. What are those? Logic 0, logic 1, and high impedance. These are three state. That is why this is called as a tri-state device. Now, what does it mean? It means that, so when input is 0, output is 0. This is one stage. When input is 1, output is 1. That is second state. So when it is connected, you are going to have two state, logic 0 and logic 1. When it is open, it is called high impedance. It means input is no more connected to output. That is what we call as third state, right? So 0, 1, and high impedance state. Okay, so these are the three logic steps which are available in tri-state device. That is why it is called as three-state buffer. Basic output device is set of latches. So input device is going to be buffer. Buffer means, buffer is the device which will enhance the current capacity of the output section. Okay, let us say you have got one amplifier, right? Whose source current is going to be let us say 3 milliampere, right? But we want more than that, right? We want more than that. It can provide 3 milliampere of current maximum, right? But we want 5 milliampere. What do you need to do? You need to have buffer circuit in it, which will help you to enhance the circuit, enhance the current capacity. Okay, so buffer are being used to enhance the current capacity of the output devices. The basic output device is a set of data latches. As far as output device is concerned, it is a set of latches. Latch is kind of memory element. Latch is kind of a memory element. So memory element is need to be there as far as output device is concerned. Why it is needed, that I'm going to discuss in due course of time. The term in refers to moving of data from input device to the microprocessor, and out refers to moving the data from microprocessor to IO device. Three-state buffer are used to construct 8-bit input port depicted in figure, which is going to be on next slide that I'm going to show you. The external TTL data are connected to the input of the buffer. Buffer output connects the data bus. I will show you that. Circuit of allowed circuit allows processor there is some mistake here. Circuit allows processor to read content of 8 switches that connect to 8-bit section of the data bus when select signal become logic 0. Now I'm going to explain. This is the circuit. So what I was trying to explain you, it is basically a three-state basic input interface. This is basic input interface, and this is tri-state device. This is a three-state device. It has got two state. Two state means when input is 0, output is 0. Input is 1, output is 1. When it is connected. So when it is connected, when input is connected to output, whatever status you are going to have at the input, the same is going to be appear at the output. And that is why it's called, when a logic 0 is one, when there is logic 0 at the input, it is going to be logic 0 at the output. When there is logic 1 at the input, there is going to be logic 1 at the output. Third step is going to be input is not connected to output. This is what we call as high impedance, right? So logic 0, logic 1, and high impedance. So 74A LS244 is one of the very standard IC which is being used as a tri-state buffer. Why this is, if input is same, if output is similar to input, then why this is needed? Enhance the current capacity, as I mentioned earlier. Because buffer is being used to minimize. This is one of the input interface. This is one of the input interface. Without this, you cannot interface any device. If you really want to, let's say keyboard, if you want to interface keyboard with microprocessor, you cannot interface directly. That need to be interfaced through this basic interface circuit, right? Which is called as buffer circuit. You can see this is, and then these are the set of switches, right? Set of switches. Okay, we have got 8 switches, right? So when this point is connected to this, it means this is closed. This switch is closed. There is open, this can never be connected to this. Okay, so there are 8 different switches, and here this, through this resistor we have connected to VCC. What does this means? You can see, if whenever this switch is in closed state, okay, this 0, because the other terminal is connected to logic 0. Other terminal is connected to logic 0. So automatically when this switch is connected, logic 0 is going to be transferred here. When switch is connected, logic 0 is going to be transferred there. And when it is open, what happens? When it is open, it is going to be connected logic 0, logic 1, because this point is connected to VCC through these resistors, right? So when this switch is closed, logic 0 is going to appear at the input. When it is open, logic 1 is appear, right? So here logic 0, output will be logic 0. Here logic 1, output is going to be logic 1. These are 2 states. Third state would be when this is not connected at all. This input is not connected to output. What will happen? Irrespective of the status at the input, output is going to be high impedance. Irrespective of the status at the input, output is going to be high impedance. So this is the basic interface circuit which is being used to interface keyboard. Like this is simplest example. So what we have done, we have interface keyboard through this interface circuit. And what is the name of this interface circuit? Name of this interface circuit is the tri-state buffer. It is name of this is tri-state buffer. Now, whenever you put, there are 2 different control signals, 1G and 2Z. Okay, you can see this is bubble. Bubble means this is active low. These 2 terminals are active low. So we have, what we have done, we have connected both together and connected to ACL. ACL is a select signal. Select signal means select chip signal. So obviously, since this is logic low, logic 0, you have to connect logic 0. So whenever you will be connecting logic 0, automatically the chip is going to be selected and enabled rather, and then like if this is connected, logic 0 is going to be transferred at the output. If it is open, logic 1 is going to be transferred. So when in instruction execute, the content of switches copy the AL register. Okay, and this basic input circuit is not optional and must appear any time input data, whenever input data interface to the microprocessor. This is not optional, this is mandatory circuit. Right? Sometimes it appears at a discrete part of the circuit as shown in the figure. It also built into programmable IO device, but I'm not going to discuss that programmable IO device because this is the fundamental input in basic input interface circuit, right? So you can have the PLD also, like in the PLD form, but that I thought like that should not be included here. Similarly, we can have the basic output interface. So basic output interface receives data from processor and usually must hold it for some external device, So what happens whenever you want to transfer data from processor to output device? So what you have to do? You need to hold that data for time being. And therefore you need latches, because if you don't hold the data, then it will be very difficult for you to visualize the data, because within no time it is going to be disappear. Logic 1 or logic 0. So that is why you need to hold it for a while, and therefore at the output we need latches, or we can call it as flip-flops. Like buffer in the input device are often built into the input device. Similarly, latches are also built in the output device. In most of the devices nowadays, most of the devices are having buffer in the input inbuilt, and similarly latches at the output inbuilt. You don't need, truly speaking, extra devices, but we need to understand like how the IO devices can be interfaced. The figure which I'm going to show you on next slide will show how 8 light emitting diodes can be connected to the processor to transfer data to the devices. Latch stores the number of output by the microprocessor from data bus so that LED can be brightened, and 8-bit binary number can be displayed. And this is the simple output interface circuit. You can see here, this is the latch. This is the latch. So this is data bus. Input of this latch is the data bus, and output is going to be connected to LEDs. Now, without this, if you connect this to the LEDs, then it will be difficult for us to visualize the data. So in order to visualize the data, this latch is very, very important. And these two are control terminal. This has to be connected logic 0, as this is called as the output, enabling input, and this is clock signal, right? So you need to be, this is H trigger. You can see this is a negative H trigger clock pulse. So this is the latch. 74ALS374 is the name of the device. So latches hold the data because when the processor executes an out instruction, data are only present on the data bus for less than 1 microsecond, and it will be difficult for you will never see LED illuminating, right? Because it's not going to hold the data. Data is not going to hold the data for more than 1 microsecond. And when out execute, data from AL or AX transferred the latch via data bus, and you can see the data. Okay. Each time out execute, ACL signal activates computing data, flash the data, because these ACL signal need to be activated. This ACL signal need to be activated so that the data can be transferred to the output. Otherwise, data is not going to be transferred to the output. Handshaking signal we are going to discuss in the next lecture. Okay.